Hello everyone. Let us continue our discussion on equations of motion using graphical method. So these three equations we want to derive. First one we have derived in last video. We will focus on the second equation in this video. Again with the same graph and same notations we will go. U is the initial velocity, V is the final velocity, T is the time interval or time duration, A is the acceleration, S is the distance traveled by the object. There are three conclusions from the distance time graph and velocity time graph. The slope of the line in distance time graph gives us velocity. That is the first one. Second conclusion is the slope of the line in velocity time graph gives us magnitude of acceleration. And third, the area under the line or area under the curve in velocity time graph gives us the magnitude of displacement. So here area under the velocity time graph gives us the magnitude of displacement. With this basis we will move ahead. So now we want to calculate the displacement. So I need to consider the area under this curve or area under this line AB. Area under this line AB is nothing but area A, B, C, D, O and A I will consider. And for better understanding, we will divide this area in one triangle and one rectangle. Triangle is ABC and rectangle is rectangle OACD. We have divided the trapezoidal into two parts. Now, this is the triangular area and this is the rectangular area. Let us calculate the area of this triangle ABC. What is the area? Obvious, 1/2 base into height, and area of this rectangle OACD is nothing but length into breadth. Now, displacement S is equal to 1/2 base. AC is the base of this triangle and BC is the height of this triangle. AC into BC is plus. For the area of the rectangle, what is the length? Length is OD and breadth is OA. Right. Now, AC distance I can replace as distance OD. So AC here we have replaced by OD. Then BC, B to C distance is nothing but distance BD minus distance CD plus OD into OA as it is. Now we will just replace with velocities and time term. OD is nothing but the time interval. BD, B to D distance is nothing but the final velocity V. B to D distance. Then C to D distance is nothing but initial velocity U. OD is T and O to A distance is nothing but initial velocity U, right? This equation we have derived in the earlier video. V is equal to U plus AT. Just I will take this U term to the left hand side. So V minus U is equal to AT. Using this, we will derive this. Now, same equation I have written here. Only this V minus U I have replaced with AT. Here, V minus U I have replaced with AT. So 1/2 T into AT plus T into U. Now, if you multiply the T inside, so it will give T into U plus 1/2 T into AT, which is nothing but S is equal to UT plus half AT square. S is equal to UT plus half AT square. This is the second equation of motion, which represents the relation between displacement and the time, position and time. Okay. The third equation we will derive in the next video. Thank you.